Hi all. I take a reasonable guess that most of you are either QA or people interested in testing. And I believe that you had encountered this situation. You start working for the new company and old project with lots of problems in the different areas. But one of the things you notice is the lack of proper CI/CD setup for delivering new code. Or it's a greenfield project and you don't know how to begin, so you not end up with hard to maintain project. You want to integrate various automating tools. Maybe introduce some process, set up guidelines, but it's not easy task. And today I will try to cover that topic and share some of my tips and ideas how it can be done. My name is Bartłomiej Hirsch and this is Maintain Test Automation Quality Talk. I will be using tools that I have created or co-created, such as RoboCop and Robot-Tidy in my examples, but this knowledge applies to the other tools as well. Let's present this as a journey that you may take, and with tools like RoboCop or Robot-Tidy, you first start simply in the terminal. So you pick some tools to start with, like linters or auto-formatters, install them, check the documentation or help command, and then you try to run it in your project. And using RoboCop as an example, and you end up with almost 9,000 issues. But let's say you're not scared of that and you're really determined. You fix all the issues, and by the way, my record is over 100,000 issues in the project, and create an enormous PR, and hopefully the team review it and completely, and you merge it. And then you realize that in meantime, you miss the deadlines for the other tasks in the project, and you start to notice that the day-to-day work with the tool is a bit tiring since you need to remember to run it. And the worst part is that only you are using it, so you need to constantly fix someone else's code. Thankfully, all of that can be automated or simplified, and the whole process of integrating those kind of tools in the project may be a lot easier without affecting your day-to-day work. I will show you how it can be done. First of all, you want predictability and to achieve the same results for everyone. So you want to run the same version of the tool, and also you want to use the same configuration. You obviously may pass some long command line in the team, but it will not be handy to use. It's a lot better to create a configuration file. And to avoid chaos in the repository, if the tools support the same common configuration file format, then you should use it. In case of the most popular Python tools, it's usually the pyproject.toml file. Here you can see such example. I have stored some configuration for the black, isort, RoboCop and Robot-Tidy here. Now, when you run the tool, usually it will automatically discover such file and load the configuration. If not, then maybe you need to pass the configuration file in the command line first. You will need to check the documentation first. And once it's done, you already have predictable configuration. Now it's time you need to think, what kind of issues you want to catch. You saw it. You have 10,000 issues or more. What I do recommend is using divide and conquer strategy. Focus on critical stuff first. Check the documentation and include only errors, and then slowly include more. And when you change the code and later create merge request in the repository, it's a lot easier to review and see the scope of the changes if you focus on fixing single issue. If you create PR for fixing 10,000 issues, nobody will read that, and you may miss some bugs, and obviously people will not know what was changed and why, so they will keep repeating the same mistakes. To help with that approach, Robot-Tidy offers a generate configuration option. So let's first check the help. And you can see you can use this generate config with optional configuration file name to generate the configuration file. Here you can see that it actually generated the default config.tom file, which contains all the default settings. Now you can just review it and see what is important for you and what you need to configure. For example, you might need to show the difference in the file, or you might configure, enable or disable particular transformers. You can see that most of them are enabled by default with some exceptions. And at the beginning, I would recommend you to just enable a single transformer and then just go from there. Generate config allows you to also read the configuration from the command line. So if I pass transform add missing end, it just produces the same default configuration, but you can see that all transformers except for one are disabled, which is reflecting the configuration passed from the command line. Now you can simply pick one or more initial transformers that you want to run for your first runs. Personally, I would recommend normalize new lines. It just simply removes extra or adds missing new lines. Or you can also try to run normalize separators to put fixed separators everywhere. With that configuration, you can try to run the tool. In RoboCop, we don't offer such option yet, though by the time you watch this, it could change. But you can simply add include option in the configuration file and only run rules that are included. So let's start by browsing the available rules using the RoboCop list. You can see there is 142 rules, so we have a lot of rules to pick from. But like I said, let's start with errors. For example, I would recommend using the parsing errors first, and then just go from there and check the documentation to see what's important for you at the very beginning. Okay, then you proceed with that and you slowly start fixing your project. But you notice you sometimes forgot to run the tools before pushing your changes, and your colleagues often don't use it at all. And our solution for that is, of course, automation. Git have something called Git hooks, which can be used to run any kind of script or code on various Git events like pushing, rebasing, after or before commit. In every repository in hidden Git directory, you have hooks directory, which contains various examples of such hooks. What we are interested in are pre-commits, since we want to run something every time you're trying to commit something. Now you might, to create your bash or any other script, install the tools and run them. But still, it may be bothersome to set up it by hand, and that's why you have tools for that. And we will be using the pre-commit Python tool. You can just install it by running pip install pre-commit. Pre-commit by default looks for pre-commit config yam file, which describes what kind of hooks needs to be executed. You can either specify local files, for example, Python script to check content of commit message if it starts with specific word like fix, feature, maybe Jira ID ticket, or special check to assure that every new file is starting with copyright notice. Or you can run external tools. Those can be specified by using git URL with the name of the tag. Usually most tools are using git tags when releasing new version, and we are using that to specify the version of the tool. Also, the target repository needs to have equivalent file that describes what exactly hook is doing. And let's see this on a Robot-Tidy example. You see this pre-commit hooks file, which contains name of the hook, what kind of files it applies to, and so on. You do not need to create this file. It's just that the tools that we are using need it in the repository root. And if they don't, there are other ways of configuring tools described in the pre-commit documentation. But it just makes it easier for you. And when using pre-commit for the first time in the repository, you need to load the configuration using pre-commit install option. Later, on the first use, it will create virtual environment for your tools, install them and run. So the first run might take a few minutes, but then next ones are way faster. And by default, pre-commit register itself as pre-commit hook, so it will run your code before pre-commit, but you can of course configure it to run on any other Git events, for example, before pushing your code. Let's see this in an example. And we are back to our example project. You might see that I have added a new test case, which is using the keyword defined in the same file. You can also see that I have introduced a new variable, but I forgot to use it. I used the hard-coded string instead. Also, in the send process request keyword, I'm using the return setting, but now we have a better alternative for it starting from Robot Framework 5.0. All those issues should be either catched by RoboCop or fixed by Robot-Tidy. But now, instead of running those tools manually, it should happen automatically before you commit your changes. Since it's the first time we are using the pre-commit in this repository, we need to install it first. Using the pre-commit install, the pre-commit will read the pre-commit configuration file and copy the configuration to the Git hooks pre-commit directory. So the Git will know what to call when we are committing our changes. Now let's verify what we are about to commit. So we are seeing that I modified only this file. So let's add it and let's create our commit. Now pre-commit or rather Git raised the pre-commit hook event and our tools were executed before committing our changes. You may see that isort and black were skipped because we modified the robot file and those tools work with the Python files. Instead, you can see that Robot-Tidy was executed and returned non-zero exit code, which interrupts our commit, and it shows that it modified our file. It replaced the deprecated return setting with the new return syntax. Also, RoboCop raised two issues. You can see that variable expected message is assigned but not used, and also the same is for the response variable. Oh, you may see that I made a typo here. So let me fix this issue and let me reuse this variable here. So now our code should be good to go. Let's add changes again. And since the pre-commit interrupts our commit, we need to commit it again. Now you can see that everything passed. And I can see from the Git log that we have only two commits, one with our fixed changes and without the RoboCop issues. And it is that simple. So you can easily use the pre-commit scripts to run any external tool, but also internal scripts. For example, like I mentioned, you may check the content of the commit message, or if your new changes apply to some to your company guidelines. You can also run unit test or integration testing before you commit, but unless your tests take very little time, I wouldn't recommend it. It's usually better to do this in the CI, but if they take a few seconds or you just define this on the pre-push event, it might be a good idea to do this also locally. This topic is broad. Depending on what Git provider or Git server your company is using, setting up pipeline may be completely different. From the most popular Git providers, you have GitHub, GitLab, Bitbucket, and now the cloud providers also have solutions like Azure Repos, AWS Code Commit, etc. All of those have their own integrated solutions for running the pipelines, like GitHub Actions or GitLab pipelines. And if your company uses the tools integrated with your Git provider, you're already lucky, and it may be a lot easier to set up your first pipeline. But usually it's a bit more complicated. Just take, for example, the company that use the self-host Bitbucket with all the external plugins disabled for the security reasons. And to run the pipeline, they are using the Jenkins instance. But for some reason, it's one of the older versions. Also, you quickly notice that whatever you find in the internet guides does not work in your company, because you have your own infrastructure as code solution, which needs to be used to create new jobs. So whatever I could show you might not work for you, even if you are using the same tools. That's why I have just general advice here. Start by observing of whatever is already defined in your company and just copy and adjust it to your needs. Maybe developers have the pipeline for building and testing the code, or there are other automated jobs. Take it and reuse it for your own needs. In the next example, I will be using the Jenkins script, but you should be able to reuse the approach itself in any other build engine your company is using. Here you can see an example of the Jenkins pipeline, a very simple one. And you can see that it consists of several stages. The first stage is checkouting the code of your repository. The second stage is installing the dependencies. And of course, depending on your needs, you might also define the Docker image, build it elsewhere and just reuse it here. Or you might install the dependencies in every run of your pipeline. Another stage is running our static checks. And I will just park here for a while. So you can see that I'm running the two tools, RoboCop and Robot-Tidy. RoboCop returns non-zero exit code by default if he detects something in your code. Robot-Tidy requires extra check option in order to return non-zero exit code. It works similarly to any other auto formatter. So for example, we have black. And we also can define the check in order to fade the pipeline if black or Robot-Tidy modify the code. Instead of running the tools one by one, you can also reuse the same approach you are using locally. So you can run pre-commit, but not on the files changed in the commit, but on the old files. Okay, now you need to think how you want to present results of running your tools to the user. Of course, if the pipeline just passed and everything is green, then that's fine. But if RoboCop finds something or Robot-Tidy auto-formats your file, you want to inform the user what they need to change in order for the pipeline to pass. And it heavily depends on what build server you are using and what plugins you are available for you, etc. The simplest sharing the results is just copying the output of the tools and storing it as artifact, or just simply displaying this in the stage as we were running the tools. But most of the tools are supporting the common output format. For example, RoboCop supports the Sarif format, and it's the same for the other popular linters. This Sarif format can be, for example, used in the GitHub or GitLab to be automatically read by special actions, and then it will display the issues next to your code. So it's very easy to see what's wrong. Let's see this in an example. Here we have a pull request that I have open in the RoboCop repository. And in our repository, we are running multiple checks. So those are linter checks, pre-commit on the remote branch, end-to-end test, unit test on the several platforms, etc. Since we are having our test framework to test if our rules are working correctly, our test data is just full of various RoboCop issues. Because of that, we are usually not running RoboCop on our test data itself, but especially for this example, I have introduced one RoboCop issue and then run a special check that uploads the Sarif report to the GitHub to show you how it works. In this case, I have added new line here, which contains invalid code. It should raise the missing blank space after comment character. And you can see how GitHub is integrating well with this Sarif report, and it displays where the issue is in your code exactly in the file view. And the similar possibilities exist for the other tools as well, for the GitLab Bitbucket, even for the Jenkins itself with the warn next warning plugin. You can also see that you can display more details, and it will show extended documentation on the rule with some good code and bad code and configuration examples, which makes it a lot easier for the other people in your team to understand why this issue was raised, rather than just dry one line warning from the output. And for that reason, instead of trying to parse the tool output by hand manually, try to first check if it offers some common output format, and then if your Git provider can load and integrate this format into the view. It may help you a lot with displaying the results. Okay, that concludes the run static check part. Then let's assume that every issue from the RoboCop or Robot-Tidy was fixed, and you are going to the next stage, which is the robot dry run mode. I think it's one of the most underestimated options in the robot framework. Robot dry run mode, as the name suggests, is dry running your code without executing the keyword itself. So it's exploring your code, checking if the dependencies imports are declared correctly, if the keywords can be found, or the number of arguments are passed correctly to the keywords. And whenever it finds any kind of issue, it will fail execution. Let's try to run it inside our example project. But to be more realistic, let's introduce the sleep keyword 60 minutes here. And of course, if you would want to run the test to see if everything is correct with the test itself, it will take at least 60 minutes. But instead, we can run the robot dry run here. And of course, it fails since it is example project and I didn't set up it correctly. But let's open the log and see what's wrong. You might see it complains that it couldn't resolve the path to the resource file and library files. And it will be the same in your repository. So if you, for example, forgot to install the dependency, or you put the invalid path, if it also fail. Similarly, I introduced some unknown keyword here, the get application status. So it fails with the message that this keyword doesn't exist. And here with the post on keyword. And you also see that even if the whole test would take at least 60 minutes, the dry run itself took less than 1 second. In very big projects, like thousands of test cases, it may take less than minutes or few minutes tops. So it's still a lot faster than running all the tests, and may help you catch any kind of typos or issues with your dependencies, etc. When you first run it, you might need to spend a bit more time in order to fix your code, in order to dry run to work. You may have existing issues, or maybe you are using a lot of dynamic variables, dynamic imports, etc., which are not supported by the dry run mode. But still, I believe it's worth to try to use the dry run mode in your CI/CD pipeline. Also, if you have some issues that cannot be resolved in the robot dry run mode, but you still want to use it, there is special tag called no dry run. So when I run it, it will ignore the keyword or test case where this tag was defined, and now you can see that I have one test case more which is passing. And let's go back to our Jenkins pipeline. Our another stage after the robot dry run mode is the unit test. And by unit test, I mean unit test for your test libraries. So when you are writing the test libraries, it can be the big Python libraries, which is consists of hundreds, thousands of lines, and it is still the code itself. So you want to ensure that this code is working. But because it is the test code, you don't need to have 100 coverage here, but I still think it's important to at least define some basic unit tests for your libraries to see if they were working correctly after some refactor or changes. And another last stage is smoke test. So if you have any short test to run, you might also want to run one or two such test cases in your CI/CD pipeline to see if the proposed change doesn't break anything in your code repository. And that's it for your first pipeline in your test repository. After you run all the stages, you want to report your result back to your Git provider. If you have integrated solution like GitLab Action, it may happen automatically. In case your run was triggered using the webhook or plugin, for example, in the Jenkins, you might need to use either a special plugin like GitLab commit status, or use the API of your Git provider like Bitbucket API in order to post status of your pipeline back to the open pull request. Okay, we went for automation on your local machine, then running CI/CD pipeline, and assuming all went good, we should be ready to merge. But we are not done yet. We are left with most important step, the review. It's a tricky subject, and when I see the developers really not doing the reviews these days, the tests are not treated the same. They are often merged directly, and I believe it's the major problem, and we always should the reviews. Some of you may ask what to do if you are the only one QA in the team. Well, of course you can ask the developers or other QAs in the company. Even if you don't know the context of your change or the business logic, they will still be able to help catch any typos or areas in the code that should be improved. I'm also doing something I called self-review. So I'm leaving my change for an hour or more, then I'm going back to it and I'm reading through the changes. And I often catch something at this point. That's why I think that even if you don't have the CI/CD pipeline or you are not running any automation to improve your code quality, you still need the review. It's the first step for improving the code in your repository, since it's the easy way of instantly improving the quality of the code. And now you should be able to merge your change. But what if you still miss issue in your test itself, and after night regression you are getting the flaky test? For that, we cannot forget about the monitor part of the DevOps principles. First of all, you obviously want to run the test and observe how they behave after the change. But in case something goes awry, you want traceability of your change. You may be using advanced Git flows practices in your repositories, or you simply create feature branch and merge it directly to the master. But in order to trace your changes, you want some kind of versioning. I often see it's missing from the test automation repositories, and I later see the logs from the 2 different days. One is failing, but I'm not sure if it's application issue or the test issue. With some kind of versioning, I would know that, for example, one of the logs is using the new version of the test library after the big refactor, and it should be main suspect first. Here I have a short tip for you. Use the metadata in Robot framework. Let's see this in the code. We are back to our example project. You can see that I have created the init robot file inside the test suite. which contains the static section. Here I have number of metadata, and metadata is key value pairs that may contain some information that will be displayed in the robot framework log. It can be static information, like for example, I just put the test version using the string constant here, but it can also use the variables. Here I use the environment variable, or it can contain evaluated Python expression. In this case, I use the robot framework version, evaluating the variable from the robot package. I can do the same for my Python test libraries, and thanks for that I can display some dynamic information that will be useful for me later for monitoring part. Let's run the test and see how it will look like in the log. Okay, let's open the log. Here you can see the log from my execution, and if I go under the test suite, you will see all my metadata. So we have the environment, which is the value of the env variable dev, and we have the robot framework version 6.1.1, and now we have my test library version evaluated from my package, which is 1.11, and the test version 1.1. And thanks for that, you can easily refer to the settings you used when running the test, and later use that information when analyzing your test results. Okay, that sums up the brief introduction to how you can manage the development of your test. It of course just scratched the surface, but I hope it will be a good starting point for your team. Thank you for watching.